Okay, today we're going to be on 2.2, going over point slope form. Main object of today, we're going to be writing and graphing linear equations in point slope form, and we'll analyze the different forms of a line to interpret the slope in the y-intercept. Because as we recall from the previous section was titled slope intercept form, okay? And that was the equation y is equal to mx plus b, okay? Where in order to use this equation, we would need to know the slope and the y-intercept. In this one, you can probably go ahead and take a guess here. We're going to need the point and a slope. Now, the goal of this is to be able to look at the equation of a line because it may be in different forms. And instead of trying to commit and convert every single equation to a same like slope-intercept form, if it's already in point-slope form, then we can get our information that we need to not only identify the certain parts, but also to graph it on our coordinate grid, okay? Now, the first example here is going to be more of a how do we get the equation for point-slope form, okay? So we're going to convert the slope formula into point-slope form, okay? And as we recall, the slope formula, m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, okay? Now, to kind of illustrate what we're going to do here, we don't have to do too much of trying to solve for a certain variable or anything. There's only really one step we have to do, but students will get confused a little bit on this. Trying to fix my 1 right there, okay? For instance, if I gave you the equation 6 is equal to x over 3, and I said you had to solve for x, you would simply get rid of this divide by 3 by multiplying both sides by 3. When we do that, these 3's on the right would cancel out, and then we would go about our business. Okay? We were dividing there, so we multiplied by what it was. Here, we want to get this x sub 2 minus x sub 1 off the bottom. So to get rid of that division, we're going to do the same thing. We are going to multiply it by x sub 2 minus x sub 1. Okay? And just like we did over here for this one, when we do to one side, we have to do the other. So if we're going to multiply the right side by x sub 2 minus x sub 1, we are going to have to do that to the other side as well. Now, the x sub 2 and the x sub 1 here, the x sub 2 minus x sub 1s we have here, since we're dividing and multiplying by that, they're going to cross out, leaving us just with this y sub 2 minus y sub 1 on top, which is good because we don't want to have that fraction right there, okay? Because we're wanting to move stuff around that way. If we were given a point and a slope, we'd be able to plug it in and use it to our advantage here. Now, when it comes to this part right here, these next couple steps are more of just housekeeping. And what I mean by that is we're just going to move stuff around a little bit so it's in the form that we want it to be in and kind of the easiest to understand. All right, first things first, if we take a look at our slope-intercept formula, we notice how we have the slope times our x, okay? We're actually going to try to do the same thing here. Now, what we're going to do is we're going to move the m from being multiplying on the right side. We're going to just move it out to the front to be on the left side. So we're going to move the m over here, okay, to be x sub 2 minus x sub 1. Now, don't think of this as distribution property. Eventually, we could use distribution property to simplify this a little bit, but in this problem, since we don't know what the value of m, x sub 2 or x sub 1 is, there's no point in distributing the m if we're not going to be able to simplify some things. So that's why we just kind of left it like this, because just moving the m out front is going to make our equation a little bit more easier to access, okay? Another thing we want to do here, very similar to how we have y is equal to up here, we would prefer the y's to be first. Now keep in mind, before we've had problems like 6 is equal to x, and we were able to say, well, x is equal to 6 because we're able to flip around because it's reflexive, okay? We're going to do the same thing right here. So let's go ahead and move those y sub 2 minus y sub 1 out front, and then we'll just move the slope times the quantity x sub 2 minus x sub 1 to the end. Okay? Now we almost have this actually in the form that we want to have it in, which is point slope form. But the thing is, in order to use point slope form, we only want to use a point and a slope. Now we do have a slope right here, but the thing is, I have x sub 1, y sub 1, that's 1 point. I also have this x sub 2, y sub 2, which is the second point. Now we don't need the x sub 2 and y sub 2. But we're not going to get rid of them completely because we do need the variable. Just like up here in the slope intercept one, we have the y here and the x here, all right? helps us out in distributing or in determining our equation. All we're focused on actually getting rid of, though, are the 2's right there. So if we drop the 2's, we would be left with y minus y sub 1 equals m times the quantity x minus x sub 1. Okay? Now, in doing that, we are able to get our equation here now to be what we want it to be, which was point slope form. Okay? Because we have the slope right there, and we have the x sub 1, y sub 1 right there. So this was the equation we were looking for here. And we can actually manipulate this one around a little bit to make it actually look like this one. And we're going to get into that a little bit later on in this chapter. But for the sake of what we're doing here, this process, we're able to use this formula because, as you notice, we really didn't do too much. We just moved stuff around, okay? That's why we're able to use this formula and helping ourselves out, because now we're able to use this to help identify some data and be able to use it to graph. So we're going to take a look at these first two examples here. If you want to try them on your own, here's the time you can do that. Okay, so let's take a look at what we have here. They tell us to use the following information to create an equation in point slope form. So since we know we're going to use point slope form, we should go ahead and write down that equation. Now, it might take a little bit of time to remember this formula right here, but once again, it's pretty easy because once again, we should have a point, x1, y1. We should have a slope with the m right here. And it's always easy to determine. It's always going to be y minus y and x minus x, okay? But just keep in mind the y's are always first out here, and the x's are always inside the parentheses. Now, in this information, we know that they tell us that the slope is 3/4, and that the point that they give us is 2, -3. Since this is the only point that they give us, we'll go ahead and let this be our x sub 1, y sub 1. In which case, we have all the information we need. We just need to plug in everything. So we'll have y minus our y sub 1, which is a -3, is equal to x, which is 3/4, times the quantity x minus our x sub 1, which is 2. Okay? Now, what I will go ahead and tell you, if you're watching this video for my class, the IXL lesson that we assigned for this, it's actually going to want you to fill in the blanks. So it's going to want you to fill in a blank there, fill in a blank there, and fill in a blank right there. So it's going to have y minus a blank is equal to a blank, parenthesis x minus a blank. Okay, and the reason why I'm identifying this is, one, you see how it's pretty easy with the IXL we assigned because we just have to plug in the y for the y, the x for the x, and the slope in for m here. Which, once again, the y's always go with the y's together, and the x's always go with the x's together. And the reason why I'm making a little bit more of a deal out of this is because hopefully my students will notice that, we have this minus and negative right here. We would prefer to go ahead and combine those together to give us a negative times a negative, which is a positive. So that's a little bit better for us to put it in that form. But the thing is, if I'm just putting an answer in these blanks right here, I actually can't change it to a positive. So they're okay with actually you leaving it as y minus a -3, okay? Because this is the format it's going to be for the first couple examples. Now, eventually, some of the questions you're going to have to type in the entire equation like this one. You can actually type it in either one of these two ways. So you can leave it as the minus and negative, or go ahead and convert it to a 3, but it will still work either way. Now, in this one, this is a little bit more of a challenge one because, unfortunately, if we're trying to put this into point slope form, they give us 2 points. They don't give us a slope. So, if they don't give us a slope, but we're given 2 points, we're going to have to find the slope first. So we have to use m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Remember, our first step is always writing the formula for slope. Second one, let's go ahead and identify our 2 points. We'll let 5, 2 be our first point, and we'll let -7, 4 be our second point, the x sub 2, y sub 2. Let's go ahead and plug in our information. Y sub 2 is 4, minus y sub 1 is 2, all over x sub 2 is -7, minus x sub 1, which is 5. Now, doing the math here on the top, we'll get 4 minus 2, which is 2, over -7 minus 5 is a -12. Now, also, you'll come to realize that some students were missing problems on the last assignment because you were leaving your slope like this. You were questioning what you did wrong. Once again, you can simplify the fraction. We want to go ahead and simplify it. So since we can divide both the top and bottom of those numbers by 2, we want to go ahead and do that. So 2 divided by 2 gives us 1. Negative 12 divided by 2 gives us a negative 6. Also remember that we can go ahead and leave the negative on the bottom, or we could move it up to the top of the fraction or out front. The only thing we want to make sure is we don't add or take away any negatives. So this problem originally had just one negative in the answer. We should always remember that we want to leave one answer, okay? Because remember, if the negative is on top, okay, that means we would go down 1 because the top number tells us up and down. If the negative is on bottom, that actually tells us we're going to be moving to the left instead of the normal right, okay? But we don't want to multiply, or we don't want to put or add in more negatives because we don't want to be negative on top making it go down and negatives of 6 on the bottom making it move to the left, okay? Because that's not going to be the correct slope. It's not going to go in the direction that we want it to go, okay? So just keep in mind that the negative has several locations it can go to. But that is the slope for these 2 points. So now since we have slope, we can go to like the problem we had before, where we're going to use our point slope formula, y minus y sub 1 equal to m times the quantity x minus x sub 1, to go ahead and plug in our information. Now the one trick is here, yeah, we do have our slope we're going to plug in, but I have 2 sets of points. Now the thing is, which point do I need to use? And the answer to that is, you can use either point, okay? We can use either one of these 2 points. As long as we plug in the point correctly and simplify, we're going to be just fine. Now the only thing I'll tell students is usually I would use this point, because if I have 2 given points and I already had to calculate the slope, that means I already had to label one of my points x1, y1. And since that's what I'm plugging in down here, that's going to be what we're going to be using. So we're going to use that 5, 2 down here in this part. Let's go ahead and plug in what we know. Y minus the y sub 1, which once again we're using this point, so it's going to be 2, is equal to the slope, is 1 over negative 6, times the quantity x minus the x sub 1, which is 5. Okay? Now there's no other simplifying that we can do here, and this actually is our equation in point slope form. Now some students got a little confused today because they couldn't see how, if I plug in 5, 2 into this and got this answer, I was supposed to be getting the same thing if I plug in negative 7, 4 into the places they're supposed to go. A little bit later on here within the next week, we're going to go over an example like this where we're going to do this one point and then with the other point, and then when we simplify, which basically what that turns into is solving for y. So basically we're going to go from point slope form and convert it into our slope intercept form. We're going to show how it does work out, okay? Once again, that's for another day because we're going to go ahead and just spend some time today with point slope form. Now what we're going to do is now we need to take problems like given to us like these 2 or these 2 given examples down here, and we are going to want to graph them. Now of course we could solve for y here and distribute everything, which is putting it into the slope intercept form, but that does take a little bit of time. So what we want to be able to do is we want to be able to be given an equation in point slope form and take information from it to use to graph our line. Okay? So since I'm going to be graphing both of these up here, I'm going to let the first graph be number 1. I'm going to let the second graph be number 2, so we can tell them apart. Okay, so looking at this right here, there's 2 things we need to find. We're going to need to find the slope, and we're going to need to find the point that they gave us. So if we find the point, we'll know where to plot to where we're going to start. And then when we find the slope, we'll be able to apply that to the point they gave us to keep continuing to plot points and draw our line. Now, once again, the slope is the number, if we look at the equation up here, it's the number in front of the x, okay? It's usually in between the x and the equal sign right here, okay? So let's take a look here. In between the equal sign and the x is the number 2 over 3. So that's going to be the slope for this given problem. Now this is definitely where we had the most trouble today, was what's the coordinate points going to be here? Now, I had the majority of the students did say the answer that it was the obvious, and it is close to the correct answer. They were saying, okay, well the x and the 3 are together, so that means the 3 has to go here, and this y and negative 4 together, that means the negative 4 is going to go here. And it is actually incredibly close. But here's the thing. Let's take a look back at this previous example up here. Notice that the 2 that they gave us in this point up here for the x is positive, okay? But when I plugged it into my equation for x here, look, I'm going to have to correct myself real quick. I have no idea why I did that. And actually, let's see if I can fix it real quick. Don't believe, oh, yes I do. Okay. Let's see if we can't use this handy dandy whiteout right there. Lifesaver. Okay. I had x minus 2 already right here. Nothing changed. Hold on one second.
Renee Abram, if you were by the athletic office, did you stop it? Thanks.
Okay, so since we already had that negative right there, it's x minus 2. My apologies. Sometimes I'll make mistakes as well. So that should have remained a negative right there. So let me go back and illustrate what I was trying to say before the announcement and before my mistake. Notice that the x was 2 up here, but when we plugged it in, look what the final answer ended up being. They're opposite signs right here. And that's not just a coincidence, because if we looked at the y's, when we plugged in negative 3 over here, look what it is. It's positive. Because remember, it was y minus what these were. So the signs are going to be different from the point and the equation. So if we work backwards there, okay, if it's positive 3 in the equation, the point itself is going to have the opposite sign. So we're going to have a negative 3 right there. Okay? And then same thing for the y. Since it's negative 4 right there, we are going to have a positive 4 for our point. Okay? Now the slope does stay the same because we didn't multiply it by a negative or anything, or didn't have a negative in front of the equation. But since the other two had negatives in front of them, that's why they're going to get flipped signs. Always remember that the x is with the x, okay? The x coordinate is with the x, the y coordinate is with the y. All that's left to do for this part right here is to plot this point negative 3, 4. So if we start at the origin, go to the left 3 and go up 4, we can plot our first point. And then we're going to apply the slope 2 over 3. So it means we start at this point and go up 2 and to the right 3, place that point, up 2 to the right 3, place that point, up 2 to the right 3, place that point. And remember, on IXL, we really only need to do 2 points, but when we do them by hand, we really prefer to go ahead and graph these with about 3 to 4 points. So we use our makeshift straight edge right there, and this represents the equation, or the line, sorry, the graph, for equation number 1 here. Okay? Now, if you want to go ahead and try this problem on your own, you can pause the video and do that. Okay, let's take a look at this problem here. Let's follow the same process as we did. We're going to have to find m, and we're going to have to find the point. Now, the slope is the number in front of the x, in between the x and the equal sign here, which we see is a negative 3. And I did have some students go ahead and did the good thing here of going ahead and changing that to a fraction form, because they like to see that as a fraction, because they remember rise over run. Okay, just as a little review there. Rise over run. Top number tells us up and down. Bottom number tells us left and right. Okay. Now it comes with a point. So we had x plus 4 here. Once again, it's opposite going from equation to the point. So that's a plus 4 here. It's going to be a negative 4 there. The y coordinate was a plus 2 right there. So it's going to be a negative 2 down here. Once again, the point itself will be opposites. The slope will remain the same. Let's go ahead and plot this point on our graph over here. So negative 4, negative 2 starting at the origin. Negative 4 means move 4 to the left. Negative 2 means jump down 2. We're going to plot our point. And we have the slope of negative 3 over 1, which means we start at the point. We're going to go down 3 to the right 1, down 3 to the right 1, down 3 to the right 1. Okay. Take out our little straight edge here. I'm going to go ahead and connect my points. And that gives us the graph for equation number 2. In doing this also, we will notice that we do have a little bit of an intersection right here. And actually later on in algebra, we're going to be looking for what this is right here. This is what is known as the solution of these two lines, the intersection between them. And we'll learn that there's a couple ways that we can find out later on. Obviously, we found it this way by graphing, but then there's a couple other just straight up mathematical ways we can use to locate that point. Now, before we close the lesson on today, there is 2 things I want to address. I'm going to address them over here where I have on the side. Because there's 2 other examples I wanted to kind of bring up because I had some good questions today. I had a student ask, what if we had the equation y is equal to, and we'll just make something up here, y is equal to 3x, or sorry, 3 times the quantity x minus 4, okay? And we were asked to find slope and the point for that one, okay? So basically here, well, it's normal with the slope because once again, the slope is the number between the x and the equal sign. It's this 3 right here. And they had no problem finding the y coordinate, or sorry, the x coordinate because it's paired with the x here. So since it's -4 in the equation, it's going to be a +4 in the coordinate point. But the problem they were running into was we don't have a plus y number with our y. It's just regular old y right there. So we were getting a little confused there. So what I was just, we got to keep in mind, if we don't have a plus or y there, basically we have nothing. We try to think of what number means nothing. It's not 1, because 1 is something. The nothing number is 0. Okay? If you don't have a plus or minus number with your y, or if this would have been, if there would have been no number over here with your x, we would just put a 0 in its place. Okay? We would just put a 0 in its place. Now, just to go ahead and kind of illustrate that a little bit further, this is one I didn't do in class, so I'm just going to throw this one off at the cuff at you. Let's say we had something like this. Y is equal to 2x, which once again, the slope is the number in between the x and the equal sign, so it's still 2, but we notice we don't have plus or minus with the x, and we don't have a plus or minus with the y. So the question is, what happens there? Anytime you don't have a plus or minus with either one of your two numbers, you would just, the x's are going to be 0, and the y's are going to be the 0. So we know that this equation, or this line, would be going through the origin since it has that point. Now there is one more we're going to do. Let's say we had y minus 2 is equal to x plus 1. Okay, we got to find the slope and we have to find the point still. Now the point is probably actually easier to find on this one because we still notice that we have a plus 1 with our x. Okay, so we go opposite sign when it goes down to the point. So we'll have a -1 or a -1 right there. The y coordinate had a -2, so go opposite to the point will be a +2. And now the students got questions because there is no longer a number between the x and the equal sign. But technically there is. Even though there's no number, we do have to imagine there is an invisible 1 right there, okay? Because and the problem is most students will say, what's the number in front of the x? And they'll say 0. And if we had that, if we had 0 times x, well, that would get rid of the x altogether. So it can't be 0. So we're looking for the number that we multiply a value by and it doesn't change the value. And that value is 1. Okay, because there's a single x right there. And that means that the slope of that equation is 1. Now, of course, I did have some students say, could we write it as 1 over 1? And yes, you sure can, because it is easiest to look at the slope as a fraction. So there are 3 more examples there off to the sides that are going to kind of help us out a little bit because we didn't experience those in the other ones. But I wanted to just address them off to the side. That way we can kind of focus on just how they're different. But coming in the long run, now that we see that we have a slope and a point for each of these 3 examples, we'd be able to graph it just like we did the previous ones on the other side of this page. Okay? All right, that'll complete the notes for this section. Once again, make sure you're working on any of the missing assignments and, of course, the assignments associated with this lesson. And if you have any questions, email me.